more, but what we have is meteoroid impacts. So if we look at the moon then, the moon represents an end member because the earliest stages of differentiation, how that planet evolved soon after formation, is now frozen in time. And it gives us then an end member to look at how Earth, Venus, Mars, and Mercury could have also evolved. So if you look at the moon, you can see here we've got the near side and the far side from the Lunar Reconnaissance Orbiter camera, the wide-angle camera. These are mosaics that have been put together, and there are very notable differences between the near side and the far side. You can see on the near side we have lots of areas which are darker. These are seas or mare that were formed by basalt erupting onto the surface 3 billion years ago, although we now know maybe just a few 100 million years ago. If we look at the far side, it is very different. We can see that it is dominated by the Highlands crust material, much lighter material, because the Highlands crust is made up of this mineral called plagioclase, a calcium aluminium silicate. And we see this distributed across the moon. Very few areas of mare on the far side because the crust there, we now know, is much thicker than it is on the near side. So if we then take a very broad brush look at our moon, we can see that we have our mare or maria on the near side, where we've had eruption of lavas onto the surface and resurfacing of much of the near side of the moon through these eruptions. We then have these Highlands crustal areas, which are dominated by the mineral